Hey there, in this video we're going to cover synthetic division, which is a different way of doing long division. So what we're really doing, we have two polynomials, so you can think of this as p of x over q of x, with q of x not equal to 0. So we don't want that polynomial to be 0, but when we're dividing, we're essentially trying to see if q of x is a factor of p of x. So that's what we're essentially trying to see. So how do we divide this? So let's do it with long division, and then we'll do it in parallel with synthetic division. So long division, we draw our division box, we put the divisor out here, and we do our dividend, 2x squared plus 4x minus 5 inside. And so we go, okay, what do I multiply x by to get 2x squared? So that will be 2x. So 2x times x is 2x squared. And again, remember, you can think of the leading term of your dividend divided by the leading term of your divisor. And so that's what goes here. So multiply 2x times x is 2x squared. 2x times a negative 2 is negative 4x. And we subtract. So when you subtract, carry your negative through. So that's going to become a plus. And so when we add them, these cancel. And 4x plus 4x is 8x. Remember, it was a negative 4x, but because we're subtracting, you're essentially doing minus and minus, which becomes a plus. And now bring down the negative 5. Can I keep going? Yes, the degrees are the same. They're both linear, so I can keep going. I stop when the degree of my new dividend is smaller than the degree of the divisor. So what do I multiply x by to get 8x? So we multiply it by positive 8. So 8 times x is 8x. 8 times a negative 2 is negative 16. And we subtract. So carry the negative through. So negative 8x minus a minus becomes a plus 16. And we add them. So 8x minus 8x, those cancel. Negative 5 plus 16 is 11. So this becomes our remainder. Okay, so this is long division. So how do we do synthetic division? Some of you might like synthetic division quite a bit. So synthetic division essentially is trying to see if x equals 2 is a 0 of p of x. So with synthetic division, this is what we're trying to see. Is x equal to 2? Is this a 0 of p of x? Right? And where am I getting the 2 from? Right? What makes this 0? X minus 2 is 0 when x equals 2. So that's what we're trying to see. So we're trying to see, does 2 equals, when x equals 2, if I put it in here, am I going to get 0? So let's see. The way to do that is synthetic division. I put what I think might be my zeros, 2, and we do the inverted division box, and I put the coefficients of my p of x, of the dividend. So I have 2, so in decreasing order from highest degree, so 2x squared, so I'll just put the 2, 4x, I'll just put the 4, and the constant term is minus 5. And then I kind of draw a line with a space in between, and you'll see why. And we'll bring this 2 down. So the first term just kind of gets brought down. So I'll just bring it down, and then I do 2 times 2 is 4. So I'll put the 4 here, and with synthetic division, we add these. So 4 plus 4 is 8, and now I multiply 8 times 2 is positive 16, so I put it here, and we add 16 minus 5 is 11. And so this is my remainder. So did we get the same thing? Yes. It's just a little bit shorter. And so if you notice the numbers that we're getting, right, this 2 is the first 2 here. The 8 is my next leading term of the new dividend. And then the 11 is the, if this was going to keep going, 11 will be my next leading term of the dividend, and so on. So that's what these numbers are doing. So it's a shorter way of doing long division. So because we get a remainder of 11, that means that x minus 2 is not a factor of p of x. P of x is the dividend, the numerator, which also means in synthetic division that because we get a remainder of 11, right, something that's not 0, that means that 2 is not a 0 of the polynomial. Now check this out. I think that this is pretty super cool. My p of x is the dividend, so 2x squared plus 4x minus 5. Now, what I think is really cool, notice that if I put in my 2 in here, what's p of 2? So plug it in. So p of 2 is going to be 2 times 2 squared plus 4 times 2 minus 5. And 2 squared is 4 times 2 is 8, so I have 8 plus 4 times 2 is 8 again, minus 5. So 16 minus 5 is 11, which is our remainder. That's pretty cool. And that is not a coincidence. There is a theorem that tells us this, and this is the remainder theorem. And we also have the factor theorem. So let me grab those and put them in here. So the factor theorem says that if C is a 0 of P is the dividend, right, the numerator of a division problem, if and only if x minus c is a factor of p of x. So that's what I was saying here, that we're trying to see if x minus 2 is a factor of the numerator. So that's when we do the division. And being a factor means that then x equals 2 is a 0. So, right, in this case it will say, if I replace the c with 2, it says 2 is a 0 of p if and only if x minus 2 is a factor of p of x. And the remainder theorem, which tells us if the polynomial p of x is divided by x minus c, then the remainder is the value of p of c. So that's exactly what happened here. We divided p of x, the 2x squared plus 4x minus 5, by x minus 2, right, or x minus c, and that we got a remainder of 11. And so notice that when I plugged in then 2 into the dividend, the numerator, then I get 11 as well. So those are pretty cool, what may seem like coincidences, but they're not coincidences. So these are pretty important theorems in mathematics. So the factor theorem and the remainder theorem. So let's try another example. Okay, so for this example, so thinking of synthetic division, in this case, what do I want to see if it's 0? Right, so I'm looking at the x plus 2. So I want to see if x minus 2, or sorry, x plus 2 is a factor of the dividend. If it is, that means that x equals negative 2 is a 0 of p of x, the dividend. So that's what we're trying to see. So if I use long division, then I will just leave it as x plus 2. But with synthetic division, I'm going to use the idea of the 0. So x plus 2 is 0 when x is negative 2. So using synthetic division, I'm going to take the value for the 0, so minus 2. So think of essentially the opposite of what's in there, in my upside down division box, and I'm going to put the coefficients of the dividend. So the coefficient of x cubed is 1, then plus 2x squared minus 9x and minus 18. There are no degrees missing, so I can put all of them. If, for example, you went from x cubed to negative 9x, then I wouldn't have an x squared, so we will have to put a placeholder of 0 in there. And we draw a line underneath, and we bring the first one, comes down, 1. So the very first coefficient, we just bring it down, and then I multiply. 1 times negative 2 is negative 2, and with synthetic division, we just add. because we already did the opposite here, right? When I have x plus 2, notice that we said then we're doing x equals -2. So this is what saves us from doing the subtraction in the long division, because we are already doing the opposite. So 2 minus 2 is 0, and then 0 times -2 is 0. So bring down the -9, because -9 plus 0 is -9. And now -9 times -2 is +18. -18 plus 18 is 0. So that is our remainder. So what does this mean? We get a remainder of 0. So that means that yes, -2 is a 0. So we can say yes, x equals -2 is a 0 of the dividend, the polynomial, x cubed plus 2x squared minus 9x minus 18, which also means then by the factor theorem that then the term x plus 2 is a factor of p of x. I'm going to call this p of x. Cool. So synthetic division is a short way of doing long division, but the one thing about synthetic division is that you can only do synthetic division when you have a linear term as your divisor, because you're trying to see if something is a 0. So you have to have a linear term in there. And you can check this by that x plus 2 is a 0 by factoring this out. But we get a remainder of 0, so that tells us that it is a factor. So now how do we write that division problem? So here, right, I'm going to say that my division, which was x cubed plus 2x squared minus 9x minus 18, right, our dividend divided by x plus 2 is equal to our quotient. So this is the quotient. So because these were the coefficients up here of x cubed, x squared, x, and the constant term, we divided by a linear term, right? So looking at this, we took an x cubed and we divided by a linear term, x to the first. So we decreased by 1 degree. So our quotient is going to have an x squared, and these are the coefficients of it. So the coefficient of the x squared is going to be 1. So I'm going to have 1 x squared. And then the coefficient of the x term will be 0. So plus 0x. And then the constant term, minus 9. So these give us the coefficients of our quotient. So our final answer is essentially x squared minus 9. And now we can find all the zeros of it. So what this means is that x cubed plus 2x squared minus 9x minus 18, right, the dividend is equal to the quotient, x squared minus 9, times the divisor, x plus 2, plus the remainder, but the remainder is 0, so we don't write it. And notice that x squared minus 9 is a perfect difference of perfect squares, so we can even factor it further. And so now we can see that -2 is the 0 of this polynomial, but so is -3, and so is +3. So if you did synthetic division for all of those, you will also get 0. Okay, so let's practice synthetic division a little further. Let's do another example. All right, so for this example, I have x cubed plus 3x, x to the 5th plus 3x cubed minus 6 divided by x minus 1. So in this case, we're trying to see, what are we trying to see? So focus on the bottom one. So we're trying to see if 1, right, x equals 1 is a 0 of the numerator of p of x. So let me call this guy p of x. So using synthetic division, I'm going to have 1, and we're going to do the upside box. And now we're going to list all our coefficients. So 1 for the x to the 5th. And notice that we skip. We go from x to the 5th to x cubed. So that means that there's no x to the 4th. So that means a 0. Then 3x cubed. And wow. So here we skip from x cubed all the way to the constant term. So we're skipping the x squared, and we're also skipping the linear term, the x, and then the constant term, minus 6. And so we draw our line for the synthetic division and bring down the first coefficient, 1. So now I multiply. Remember here, I just add. For synthetic division, we add instead of subtract because we've already taken care of doing the opposite here. Right? For x minus 1, we say when x equals 1. So we already did the opposite there. So 1 times 1 is 1. So I put it here on the second one. And we add. So 0 plus 1 is 1. And 1 times 1 is 1 again. And we add. So 3 plus 1 is 4. 4 times 1 is 4. And we add. So I get 4. 4 times 1 is 4 again. So I get 0 plus 4 is 4. 4 times 1 is 4. And negative 6 plus 4 is negative 2. So this is my remainder. So is it a 0? Right? This is nope, not a 0, because the remainder is something other than 0. So what's the answer then to our division problem? So I had x to the 5th plus 3x cubed minus 6 over x minus 1. So this is going to translate to, notice that we had x to the 5th over x, so it decreases by 1, the degree. So this is going to, these are the coefficients starting with x to the 4th. So I'm going to have 1 x to the 4th plus 1 x cubed plus 4 x squared plus 4x plus 4. So these are my coefficients. And I did have a remainder, so I'm going to have plus negative 2 over the divisor, x minus 1. So that will be the final answer for this. So it depends what we're being asked. So is it a 0? No. What's the quotient? Then I will write it all like this. You don't have to write the ones, but I was just going over what this means. Yeah, so the important thing for synthetic division is you have to have a linear term here. As soon as you have an x squared or a cubic here, then you have to do the regular long division. So one more little thing. Let's say my next example, we're going to try to find a polynomial given some zeros. All right, so in this example, find a polynomial of degree 4 with zeros at minus 2, 0, 1, 3, and the coefficient of x squared is negative 10. So because I know that these are zeros, so that means if minus 2 is a 0, that means that x minus a minus 2 is a factor. Right, so that means x plus 2 is a factor. And likewise, then x minus 0 is a factor, x minus 1, and x minus 3 are factors. And so then I just multiply them all together. So my polynomial is going to be the first factor, x plus 2, times the second factor, times the third factor, times the last factor. And we multiply this all out. So what I will do is move my x over to the beginning and x plus 2 to the front. And then multiply these. I will probably do x plus 2 times x minus 1 first, and then do the x minus 3. So when I multiply these all out, I get x to the 4th minus 2x cubed minus 5x squared plus 6x. So I do have a degree 4 polynomial, and all of those values are zeros. But it says that I want a coefficient of negative 10. So how do I get a coefficient of negative 10 with the polynomial that I have? Coefficient of negative 10 for the x squared term. So right now the coefficient is negative 5, and we want to make that a negative 10. So essentially just multiply the p of x times 2. So I'm going to have 2x to the 4th minus 4x cubed minus 10x squared plus 6x. Plus 12x. And that gives us the coefficient of negative 10 in the polynomial with all those same zeros.